Now we will see the one unsolved example given for the homework. Example is compute the model matrix model matrix for a diagonalization of A. A is given, A it is equals to 1 3 0 minus 1. So this matrix is given, A it is equals to 1 3 0 minus 1, and this matrix we have to diagonalize. Now the solution. Step 1, eigenvalues. Eigenvalues that we can find out by formula lambda I minus A, it is equals to 0. These values, so now we will find out lambda I minus A, it is equals to, it is 2 by 2 matrix, so we have lambda 0 0 lambda minus, it is 1 3 0 and minus 1. Okay, now it is equals to 0. So lambda I minus A, it is equals to lambda minus 1, so this becomes lambda minus 1. 0 minus 3, so this becomes minus 3. 0 minus 0, that is 0, and lambda minus minus 1, so this becomes lambda plus 1. So now we will expand this one, so this becomes lambda I minus A, it is equals to lambda plus 1 lambda minus 1, it is equals to 0. This multiply by this multiply by this, it is equals to 0. Now we have lambda 1, it is equals to this is lambda plus 1 and this is lambda minus 1, so we will consider lambda it is equals to 1 and lambda 2 it is equals to minus 1, so these are my eigen vectors, these are my eigen values. Now in the second step, eigenvectors is lambda I minus A multiplied by x, it is equals to 0. Now in this one, put lambda it is equals to 1 in lambda I minus A in this equation. So 1 minus 1, that becomes 0. So this is 0, this is minus 3, this is 0, and lambda it is equals to 1 plus 1, that is 2. So this becomes 2 multiplied by x1 x2, it is equals to 0. So we have minus 3x1, it is equals to 0, and 2x2, it is equals to 0. Assume for non-zero condition, assume x1 it is equals to 1, therefore x2 it is equals to 0. So we have v1 it is equals to 1 and 0. This is my first eigenvector. Now put lambda it is equals to minus 1 in lambda I minus A in this equation. So minus 1 into and minus 1. So this becomes minus 2, minus 3, 0 and 0 multiplied by x1, x2. It is equals to 0. It is equals to 0. So this becomes minus 2x2, minus 2x1 minus 3x2. It is equals to 0. It is equals to 0. Assume x2 it is equals to 1. Therefore x1 it is equal, if x2 it is equals to 1, that means minus 3x minus 3. So minus 3, if we transfer this side, this becomes 3. So x1 it is equals to 3 divided by minus 2, that is minus 1.5. So this becomes minus 1.5. So we have v2 it is equals to minus 1.5 and 1, minus 1.5 and 1. So this is my another state vector. First is 1 0 and second is minus 1.5 and 1. Now we have eigenvectors. We can write down eigenvectors. It is equals to, what is this, 1 0 1 0 and this is minus 1.5 1, minus 1.5 and 1. So these are my eigenvectors. So now we know the eigenvectors. Now in the third step we will find out model matrix. Model matrix P it is equals to V1 V2. P it is equals to V1 V2. So P it is equals to, what is V1, that is 1 0 and this is minus 1.5 and here is 1, here 1 minus 1.5 and here is 1. So this is my P. Now in the fourth step we will find out diagonal matrix. Equation for the diagonal matrix D it is equals to P inverse A into P. So these equations we know. Now A is known, P is known. We will find out the P inverse. It is equals to adjunct of the P divided by determinant of the P. Now we will find out the determinant of the P. Determinant of the P is 1 into 1, that is 1, and minus 0. So it is equals to 1. Now we will find out the adjunct of the P. It is equals to, we will interchange the position. Here is the 1, here is the 1. So by interchanging, so we have the same elements, and this is 1.5. So this is minus a. So this becomes plus 1.5 and 0 is 0. No change of the sign is there. So this becomes my adjunct of the P. So now my P inverse it is equals to, this equals to, this is 1 by 1. So this equals to 1, 1.5, 0 and 1 divided by 1 remains same. So this is my P inverse. Is 1, 1.5, 0 and 1, because the determinant of the P is 1. So divided by 1, that becomes 1. So it is 1, 1.5, 0 and 1. So this is my P inverse. Now we know P inverse, we know A, we know P. Now we will find out the D. D it is equals to P inverse A into P. It is equals to P inverse, that is 1 0, 1.5 and 1 multiplied by A. A is how much? 130 minus 1. 130 minus 1. 130 minus 1, that is A, multiplied by P. P is how much? 1 minus 1.5, 0 and 1, 0 and now d it is equals to, here we will write down 1 0 1.5, here is 1 multiplied by this 1 3, 1 multiplied by 1 that is 1, 3 multiplied by 0 that is 0. So this becomes how much? 1 into 1 and 3 into 0 that is 0. So here is the 1. So 1 into 1.5 that is minus 1.5 plus 3. So this becomes 1.5. So this becomes 1.5, and here is 0 and here is 0. So here is 0. 0 into 0 that is 0, minus 1 into 1 is that is minus 1, minus 1. So this is my d. So d it is equals to, this is 1 into 1 and minus 1.50 is 1. So here is the 1. Here is 1.1, 1.5, and this is 1.5 into minus 1 that is minus 1.5. So plus 1.5 minus 1.5 becomes 0. This is 0. Now this is 0 into 1 that is 0, minus 1 into 0 that is 0. So we have 0 here, we have 0 here, and here is 0 into 1.5 that is 0, and 1 into minus 1. So here is the minus 1. So here is the minus 1. Now see here, it is equals to lambda 1 0 0, and this is lambda 2. Is it okay? This is lambda 1, it is equals to 1, and lambda 2 it is equals to minus 1. Again we get the diagonal, same diagonal matrix. Again we get the same diagonal matrix. This is the answer. This is the answer. So this way we can calculate it. We can calculate it.